Hey everyone. So today we are, from the IBM client engineering team. I have my teammate Prajna Nirchal and I am Sridhar Sahamurthy. I have, close to 12 years of experience in the field of AI and ML. And today I'm going to be talking, we are going to be talking about transforming industries through agentic AI and how exactly agentic AI has, brought about a certain level of, sea change in the way business transformations are happening across the industries. So both Prajna and I are advisory AI engineers. So we are going to be giving you a download of how things are working, and just to give you a brief idea of the agenda which we are going to talk about, in our PPT, in our session rather. So we are going to start with a very brief very brief understanding or a history lesson of sorts. Promise not to keep it very mundane, but the idea would be to give you an idea of how generative AI has actually evolved first. Then we are going to go into how agentic workflows have solved the LLM implementation challenges. And when I say LLM implementation challenges, I mean the issues which come up with implementing standalone LLMs, and how agentic AI has actually brought about a more robust framework in which we can deal with a multitude of those challenges. Thereafter, we are going to be looking at a sample agentic workflow just to give you guys an idea of how agentic workflows or what agentic workflows look like, because there is a lot of mystique, there is a lot of um, aura around what exactly an agentic workflow looks like. So we're going to be looking at a sample agentic workflow just to give you an idea of what agents look like, and then give you an idea of the type of agents which are there in the in the world today, because that is equally important to know, because for business transformation leaders, for stakeholders, for process managers, and for coders as well, it is important to understand whether or not a business problem can be solved using an agent or not. Because a lot of times we have come across cases where the use or the implementation of agents was not necessary. So the idea would be to understand the type of agents first, so that all of us here can understand whether or not agents need to be used. And thereafter, in post this session, probably introspect and take a call. Okay, was an agent necessary in my previous project, or can an agent be used in a future project? Thereafter, we are going to be looking at a couple of success stories within IBM. How exactly we have brought about value in the ecosystem of multiple clients, and then we'll wind it up with a demo of how exactly it all comes together by looking at a sample use case. So without wasting much time, I'll hand it over to Prajna, my teammate, and she'll be taking up the first couple of sections. So Prajna, over to you.
Thank you, Sridhar. Very good afternoon, everyone. Uh, like, I would like to introduce a little on about me and the team we are working with. So currently, I serve as advisory AI engineer at IBM, where I work with client engineering team to lead AI projects, and we are partners in this. Me and Sridhar. We focus on building cutting edge solution and helping clients to solve real world problems with AI. And with over 12 years of experience, I've worked on and led projects and delivered impactful solutions across various industries. So, based on my experience from startup to big tech, one thing I've learned is that while tools, technology, and models evolve, the real challenge still stays the same: turning smart ideas to impactful, meaningful solutions. And just like AI learns from us, I believe we can learn from each other. So here's to sharing, learning, and making today a meaningful conversation. Let's start with the evolution of generative AI. I'm sure most of us have already, used ChatGPT or Gemini to basically for simple stuff like drafting an email, writing a caption, or asking explaining, basically explaining something complex, or maybe even we might have taken help with code. It feels most natural now. We are so used to it, right? But what if I told you this smooth AI experience we now take for granted actually began just a few years ago with a breakthrough in the year 2017? In 2017, there was a paper called Attention is All That You Need, which brought a new architecture called transformer architecture. And this was the moment when machines truly started understanding the structure of human language. They started understanding the association of various words, entities, and the whole flow and semantic understanding in a wonderful way. So it's this technology that made Google Translate or Gmail Smart replies smarter, and that's how it is. So at that stage, AI could do basic things like checking grammar or finding spam ham. We call all these initial versions as foundation models. They were just learning, and just like how a child operates when they are instructed, they would do the same. Then came the instructor based tuning. You can think of this as teaching a AI to perform a particular task, like summarizing large documents or answering customer FAQs in certain tone. It was like you are giving the AI a job description, and we are instructing them, this is your task and you are meant to do this. Then around 2023, all of us know that there came a major boom, a big breakthrough in the field of NLP. That was tools like ChatGPT came into picture. And since then, basically, these have become an integral part of our life, be it students, be it marketers, be it coders, be it developers, be it HR teams, or in every real time scenarios, we all work with this because everything is in natural language. But it doesn't stop there. Next, after this came memory and planning. So now, at this particular stage, AI can retain the memory across sessions. AI can understand your preferences, follow up on tasks, and even act like a project assistant, not just a mere chatbot. And finally, today, which is 2025, it's the autonomous AI agents. So AI is not just helping us, but it also working along with us as our collaborator. Imagine now we have a software that only answers questions. Earlier, that was the case. LLMs would only answer the questions. But now you can book meetings, you can manage your schedules, you can manage your workflows, and even you can coordinate with other tools. And so basically, my day is full, and I have an agent which sees my schedule, books my appointments, and eventually integrates with other tools like food tools and gets me food ordering also in place. So you have decision takers along with you as a partner. So whether you're deep into AI or getting to know it, this journey affects all of us, because language is how we can connect and we can communicate. And now it's how we connect with machines too. Now the machines also understand this natural language. So I would like to welcome you all to the age of intelligent assistance, and where working smarter is for all of us and for masses. Now we'll cover that how agents have solved the key implementation challenges of LLMs. We are not just using AI to write or answer things, we are working with it. And that brings to a major shift from just using LLMs to building agents. Now LLMs, basically large language models, definitely they are incredible, but they were not able to take goals or reflect on the goals and take particular decisions or implement any actions. So that was a limitation with standard traditional LLMs. So for instance, let me give you a real world example. Say you are planning a business trip. With just a LLM, you would say, find me a flight to from Mumbai to Delhi next Monday. So LLM would recommend you or list or show you a list of flights, and then you say that okay, now look for hotels in this particular region near my meeting venue. Then it would give you the list of hotels as well. So see, it's helpful definitely, but you have to exactly tell what you want, and it cannot take any action for you like booking hotel for you, or booking airlines for you, or booking any service for you, or taking any action with respect to what you have asked, it cannot do. So that is what LLM lacked. So basically, they were reactive by design, wherein they are, like in case of agents, they can take actions. So now coming to agent, say you are the exactly the same use case of planning your business trip. Now what would an agent do in such a scenario is that it will check your calendar for your availability, it will find your preferred airlines and books the flight, it will pick a hotel near your meeting, and it will send a confirmation to all the stakeholders with whom you will have a connect, and it adds this meeting invites to your calendar, and maybe it also reminds you that there's a traffic coming in, so please start ahead. So this is not that just AI answers, but AI can act. So I hope you're getting the difference, that LLM was only understanding the language, or they would memorize whatever you the list of conversations, but agents with language, with memory, with planning, with reflection, they're able to take actions. And that's why the move to agents became such a big deal. Like, it's how AI becomes your true partner rather than just being a tool. Now that we have seen how AI is evolved from simple question answering to becoming a powerful collaborator in accomplishing tasks, let's dive further to understand sample agents, and also how what are the various types of agents and how are they revolutionizing our workflows. To explain more about this detail, I'll hand it over to Sridhar, who will take us through different types of AI agents and how they are shaping the future of work. Thank you,
Sure.
Sridhar.
Yeah, thanks, Prajna, for that. So as Prajna mentioned, there are multiple differences with respect to how standalone LLM agents, standalone LLMs are operating and how an agentic AI workflow operates. So this is, a very clear cut example and very simple to understand example with respect to what is agentic AI behavior versus a non-agentic AI behavior. So in the first, which is on the left-hand side of the screen, what you are seeing a simple LLM call, which is basically looking at the user query, a natural language user query, which is generate a monthly report of revenue with top performing products and risks. So what the LLM essentially has done, it has queried a static dashboard or a database or a vector database. It has generated a generic report with not many insights, and then just sent it out for review. Now, this is a standard LLM based process. Now, when we are talking about agentic AI, we are talking about more intelligence in the process. And when I say intelligence, I mean having more steps and more personas in place who are going to be taking multiple levels of actions. So, for example, if we talk about monthly business reports, what kind of actions would you, ideally want to take? When I say you, I mean any one of us, right? You would want someone who's planning that particular action. You would want an analyst who is analyzing the data which is received. You would want someone to write the report. You would want someone to format the report. You want someone to send the report via email. Now we are at an age in which all these can be done by agentic workflow. So the LLM agent essentially has that many number of agents. So you have a planner agent, you have an analyst agent, you have a writer agent, a formatter agent, and a delivery agent. Now this is what we mean by agentic AI. As you can see over here, the way the process has been transformed. You now have a very simple process which was done by just an LLM call. You are now transformed it into an agentic behavior where multiple agents are autonomously doing the tasks. We are not doing anything to you have to tell them to do this or do that. There is just an orchestration layer probably, which is essentially directing the tool to pick up any one of the agents, but the agents end up doing their task independently by means of LLMs. So that is what we mean by agentic AI. Now that we understood this particular example, it is worthwhile for us to understand the type of agents with respect to agentic behaviors, because this is also equally more important for us to understand in order to see whether or not your business use case. When we talk about I am talking about, let's say, transformational leads, business transformation folks, operations teams, IT teams, whoever it is. they should first understand whether or not their business use case can be solved using certain agents. So now we are going to use the next couple of minutes just to look at different type of agents, and then probably after the seminar is over, you guys can probably introspect whether or not your problems warrant an agentic framework. So the first one is a simple reflex agent. Now, reflex agent essentially means, hey, if there is an action, if there is an event X, perform Y. Just a simple action reaction kind of framework, nothing fancy, no, hard, no complex decision metrics or anything. It's like X happened, do Y. It's like a simple thermostat or, simple remote button, in a sense that if the temperature falls below, let's say 20 degrees in your house, increase the heat. It's as simple as that. That is simple reflex agents. Now, as you would probably imagine, if the environment changes, if there are more complexities, simple reflex agents will not perform well. Hence, we try and induce more complexities in the subsequent kind of agents, which is model-based reflex agents. Now, model-based reflex agents add a layer of memory to the simplex agents, in a sense that it knows what has already transpired, and thereafter it takes actions of what to do. Now think of, let's say, a vacuum cleaner, a robotic vacuum cleaner, which has cleaned, let's say, the right-hand corner of the house. Now it remembers that it has cleaned the right-hand corner of the house. Hence, it will not go over there. It will go to the other place because there is memory. There is that, level of data which is there in its system saying that I have already performed a certain action. Now, I need to perform certain other actions. Now, these particular kind of agents are just there for the perceivable environment, as you would imagine, and it does not have like a big goal. It does not have like big utilities. But what we have to do is we have to try and understand, if more agents can be, more complex agents can be done, which can accomplish more number of goals. Now, that is where the concept of utility-based and goal-based agents come into play. Now, just from the name, you would have probably understood that goal-based agents are expected to tackle an eventual goal. They are going to take take multiple routes. They are going to ensure that they can they take the effective actions or effective decisions to reach a certain goal, right? So now it can be just if I were to put it in simpler terms, let's say it is that you have to reach a certain location. Which route to take? What should be the traffic? Where exactly is the traffic less? Where exactly is the time taken less, and so on and so forth. So that is the eventual goal, which is being achieved by goal-based agents. Now, when we talk about utility-based agents essentially talk about what particular action needs to be done at that particular point of time. It doesn't look at the eventual goal. It just looks at the immediate cost-benefit analysis with respect to the utility which it is achieving from each action which it is performing. So this can be, utility can be used for setups where you have multiple goals, and goal-based is basically when you have one primary goal which has to be achieved. Now, last but by no means the least is a learning agent, where you have an agent which is learning over time. Now, this is a good example of what some of you might know as reinforcement learning agents, because this is essentially learning over time based on whatever it has seen, whatever patterns that it is observing. So it will collect data from whatever sensors or whatever events that has happened. It will critique that data. It will learn from it, and then it will keep optimizing its actions till such time it achieves a favorable action. So this particular agent is something which is, I would call it like, this is like the highest level in a sense, because once you achieve this, you have essentially created a very, robust robot, in a sense that it is learning from whatever actions there are, and you are reaching a level in which you are able to dictate where the robot itself is able to dictate whether or not to take an action, because it has learned from a lot of mistakes. So that said, now I'll hand it over to Prajna to talk about how IBM has actually taken tremendous leaps forward in terms of enabling agentic transformations using their own products, namely watsonx AI and governance. And we'll be touching upon these in the subsequent demos as well. So Prashna, over to you.
Thank you, Sridhar. So before I dive into how IBM is enabling agentic transformation, there was one question I saw in the chat, which was basically what is the IBM's definition of agentic AI? So IBM sees agentic AI as a way to eliminate repetitive, mundane, and time-consuming tasks, so that these AI agents can think, plan, and act independently. So the intent is that freeing clients for more strategic uh, tasks, or basically they focus on more strategical task, and not on this regular unproductive task. To ensure this, we have systems like watsonx AI, watsonx governance, watsonx orchestrate. Basically, this ensures that we deliver AI that is both powerful, smart, responsible, compliant, and fair. So this is how IBM envisions agentic AI. So I hope I answered your question. So let's continue with how IBM is transforming this space. So let's imagine your work. Basically, you're working as an HR in company, and your team handles hundreds of resumes, interviews, and scheduling of the interviews, onboarding, and employee questions every single day. Now imagine you hire a super smart assistant, one that can read resumes, screen candidates, schedule interviews, and even explain why it has picked a particular candidate. That's what Watson X AI will help you build. So Watson X AI, along with Orchestrate, in this case, helps us to build an intelligent HR assistant. So coming to model deployment, this is like giving your AI assistant education about HR. You're giving the domain knowledge to it. You fine tune a large language model so that it can understand roles, skills, and company culture, so that it will help you screen candidates more smartly, more intelligently. And you define what is that action that the assistant must do, basically, which drives the behavior of the agent. For example, it can scan resumes, match candidates. Basically, based on your job description, it can match candidates and send interview invites, and even respond to FAQs like what is the leave policy or what is the maternity policy. So this is the extent of the agent behavior which can be driven using what's next AI and orchestrate. Then comes, because since being an HR, you have to communicate with multiple systems like say Salesforce or CRMs or calendar tools or many other tools. So your assistant connects to multiple HR systems. So now it can automatically schedule interviews, check for conflicts, or even notify the managers once the boarding is complete. And finally, coming to explainability, here what basically here is where it gets smarter. The agent doesn't just choose a candidate, it tells you why it chose a particular candidate. For example, a candidate A with machine learning or data science experience of 5 years has been shortlisted. So it will give you the reason, or it will be able to explain that why it has chosen this particular candidate. So that is the power of transparency for recruiters. So this is about watsonx AI. Now moving to watsonx governance. Basically, watsonx governance makes sure your HR assistant is more responsible and fair and safe. So all of us know that especially these data, there's a lot of sensitive data points like resume, salary ranges, personal information. So this is where watsonx governance steps in to keep things safe and fair. For example, it tracks lineage and approval history. That is, you can see who trained that model, what data was used to train the model, and who approved it. So this ensures fairness in hiring. And coming to policies and safe actions, you can make sure that the AI assistant doesn't make offer or access salary details without any human in loop or without any third HR in loop. Finally, only certain data should be allowed to access, like you and it, basically this should be this it should have availability to education experience, while protected attributes like ethnicity, gender, or such information, critical information or sensitive information, uh, the permissions will not be given to the agents. And finally, auditing and reporting decisions. Basically, if suppose someone asks why I was not selected or why was I rejected, the system can give a clear, auditable answer that's not just helpful in understanding, but also it is very ethical and transparent. So all in all, it helps in the life cycle governance of assistant model, and also to see the metrics on month basis, basically tracking the models as well. So what's next AI here gives you a powerful HR assistant, which is fast, smart, and powerful. Why? Watsonx governance makes sure it's also fair, compliant, and trusted, and also responsible. So together they can transform how HR team works, letting people, basically it ensures that now the HRs can focus only on the people, whereas the process is taken care by AI. That's how IBM is enabling or agentic transformation, and also that's the definition of agentic AI from IBM. Now coming to success stories. As a client engineering team, we have worked on quite a few pilots with multimodal agents and AI as well. But here we have tried to highlight some of the most first of a kind pilots from the union. So the first one is the first one of the success story was about intelligent procurement optimization. Basically, this is a classical business problem of procurement. So imagine you are running a procurement from a large company, and every supplier sends the data in various formats and terms and contracts. The challenge here is that there's so much of variance in the data, which means you don't have any standard forms, or there are no particular standard terms. So there's a lot of manual evaluations involved, which results in delay in cost and delay in time. So this is the challenge. So what, as a client engineering team, we did was that we built a decision support model powered by Cplex optimization, wherein our objective was to minimize the time and cost. So while we proposed this and we provided this, an X factor what we provided along with this was scenario planning. So we also introduced a intelligent agent that could run what if scenarios, and these simulations would run in real time and help the demand planners or the procurement managers or category managers to get the result. So for example, like you have a procurement analyst, think of it like a procurement analyst who can instantly answer what happens if we increase the lead time to so and so days, or what if we switch the suppliers in this particular region. So basically the result of this pilot was that decision cycles were shorter. We improved the evaluation accuracy and also helped in cost saving for this client. Now coming to the second pilot, which was scalable visual content generation. This was specifically for a named lead, a famous retail team, where visuals uh, they had to generate the visuals for every campaign. So the challenge was that the retail teams needed engaging campaign ready visuals, and that too they wanted it fast, but also they had a time crunch, time limit, and budget constraints, which was hard to keep. So our solution was we built a AI powered visual generation pipeline. Think of it like a multimodal plus agentic solution, wherein you have an assistant that understands the brand guidelines and campaign themes, because campaigns changes across, because campaigns doesn't remains the same across the year, right? It changes every based on seasonality as well. So based on the campaign themes and the brand guidelines, it generates the visuals accordingly. So instead of a designer manually creating each banner or product shot, the AI could generate the multiple high quality variations automatically. The impact was that the creative turnaround time involved was reduced. It helped in lowering the design cost. And most importantly, it boosts the engagement by catering to or tailoring the visuals to specific campaigns. In short, we made personalized and on-brand content at scale. And third pilot, I would like to share the success stories of a chatbot for CRM DMS workflow integration. So this is a common challenge wherein here in this organization, they had to, the many teams were working on Salesforce for managing customer relationships, and there were SharePoint for storing the documents, and also they had ServiceNow. But because there are so many separate systems involved, the users had to constantly switch between these various platforms, and which would reduce their productivity, data silos, and also sometimes user frustration. So what solution we proposed was that, and we delivered was that we introduced a unified AI chatbot like a smart assistant, integrated all the platforms together to have a seamless experience, and also we powered the Salesforce, especially with RAG. So the outcome was that a seamless experience, no more copy pasting, no data silos, no context switching between multiple platforms, and we have automated workflows in place. And finally, uh, the smart leak reporting assistant for field technician. This was specifically for oil and gas technicians. So think that we are in an oil and gas field and you have to report the leaks. So the field technicians had a challenge that they had to manually report the leaks and they had to grade the leaks, but many a times they didn't have the, like, because of this process of form filling, sometimes incomplete or inconsistent documentation, or the filling would not be discrete to the most granular level. Sometimes data was missed, sometimes it wasn't submitted at all. So the solution what we proposed was that we introduce a smart context aware agent. So basically, we propose a mobile assistant that helps the technician with the guided checklist, asking smart, adaptive questions based on what's missing. For example, now you're reporting a leak. Technician is reporting a leak. We would ask, okay, did you enter the leak location? Then we would ask, are there any schools or offices nearby it? So this would, make them more intuitive and also make them think and take decisions. Basically, based on the questions or guidelines in the forms, the grading process also affects from the technician. So basically, it could even flags gaps and suggest next step before the technician hits the submit form button. The result was that the reports became more complete, more consistent, and reporting time was reduced. Also, technicians felt empowered in their decision making process of reporting the leaks and grading the leaks. So this is a perfect example of how AI doesn't only replace humans, because we have that notion in us that, at the end of the day, agents or AI replaces humans. You can see in this particular example how AI works along with the humans and we go hand in hand with human in loop. So as you have just seen that AI agents are not only answering the questions, they are providing the real world solutions, which is embedded in the workflows and helps in a faster decision, reduces manual effort, and drive the outcomes. So now, whether it's optimizing procurement, generating campaign, or supporting the field technicians in oil platforms, agents are really making a difference. And here we are just getting started. So this is about the success story of few of the pilots of the lot which we have tried to put it here. Now I'll hand it over to Sridhar, who will take us deeper about the capabilities of how it is being industrialized at scale by client engineering team with the help of a demo. Thank you, and over to you, Sridhar.
Thanks, Prajna, for that. So as you would have noticed in the success stories which Prajna just mentioned about, anything and every pilot which we have done has gone through these three phases. The first phase would be to understand the business, devise the solution, work with them to understand what exactly should the solution architecture be. Then you go into the model building part where you use whatever low code, no code solutions, whether you want to use microservice, whether you want to use LLMs, whatever you want to use, you end up using it. And then the last part, which is the most important part, and which is less talked about in multiple forums, is the refinement and the model governance part. Now, when I talk about governance, it is basically governing whether or not the model is performing to the best of its abilities, and is it in line with certain thresholds which we are holding the model accountable to. So now, basis this, what we are going to do right now is we are going to be talking about one framework which we have created for a financial client. Now, the financial client was a leading IBM partner for which we had created an agentic workflow. Now, the diagram over here, it seems a bit complex, but I'll try to walk you guys through it a bit more easier. So imagine you are getting essentially a natural language query, and the natural language query will go through one another IBM offering which is called watsonx Orchestrate. Now the Orchestrate is essentially responsible for orchestrating the actions which are supposed to happen later, in a sense that it acts pretty much like an agent in a sense, and the idea would be to um, divert the user query to any one of the three agents. Now, the first agent is an ES query agent. When I say ES query agents, ES stands for Elasticsearch. Now, for the uninitiated, the Elasticsearch essentially is a kind of a database. It is usually used in vector database searches, but it is, it does have its own ES query frameworks where you can write a certain query akin to SQL. The second one agent is an external RAG agent in which you are doing RAG against a vector database in watsonx Discovery. And the third one is basically an external research agent. Now, the idea would be if you are getting a user query and the agent basically decides to go into any one of these three frameworks. Now, this was essentially the pilot, and this was essentially the kind of framework which we were, which we were using. Now, this was a model. Now, this was a use case which we had created. Now, this use case is pretty incomplete without a governance layer over and above it. Now, when we talk about governance, we talk about primarily these four metrics which we are seeing on screen. Now, these four metrics might be a mouthful when we talk about words. They might be very jargonic in nature, but let's not take away from the fact that these metrics are pretty much common sense, in a sense that the agentic framework which I spoke of right now has multiple tools, it has multiple agents, it has a goal which has to be achieved. So logically speaking, the metrics which we are going to be talking about is whether or not the agent did a good job, whether or not the routing was correct, whether or not the goal was reached. It's pretty simple. It's basically just talking about whether or not the solution is working fine. So the watsonx governance, so the idea would be to curate these metrics and then make it as part of watsonx governance. So at the end of the day, when we talk about whatever metrics we are seeing from this framework, they will essentially land up on watsonx governance, which Prajna had basically spoken about. But as far as the nature of the metrics is concerned, they are supposed to give the user, give the stakeholders an idea of whether or not the framework is working, whether it is up and whether it is meeting the benchmarks or the respective thresholds. Now, yeah, sorry. So now going to the actual demo. So this is the landing page for watsonx Orchestrate, which I just spoke of. Now, the idea would be to have multiple queries being thrown at this particular UI, and the UI essentially taking a call on which agent to choose from. So the first question which was asked was, what was the close price for Apple on the 14th of March 2024? Sorry. So now here the agent decided that the agent basically got the answer first, which was $173 for the closing price of Apple. But how it decided the answer is something which is also given by watsonx Orchestrate in this case. So it essentially tells you that it has taken it from the ES tool, which was the Elasticsearch tool. So what the agent decided was that, hey, I have this query. It is more suited, it bodes well for me to take it up from the Elasticsearch tool. not from the RAG or from the search, because it makes more sense because the data is probably readily available over there. So it converted the natural language query to an ES query. Then from the ES query, it essentially retrieved the data from the Elasticsearch database. Now, as you can see, you can go through multiple steps within the orchestrate window to understand where the answer came from. Now, when you talk about the next question, which was what was the URL for SPX? SPX here is a stock over here, and the idea was for the tool to give out what exactly is the URL for this particular stock. So it decided that it makes more sense for it to do a URL search, a web search, to understand what exactly the URL is, because it doesn't make sense to do a vector search from the vector database, or an ES search from the Elasticsearch database. So it essentially did its own research and then came back. So this is the second use case in which the agent was able to give a correct answer. Now the third one is what was the summary for Palo Alto on the 21st of February 2025. Now this probably attains to let's say a meeting which would have happened somewhere, or with respect to, let's say, a financial report or whatnot, right? So here, as you can see, you are looking at the stock summary, which was retrieved from the vector database based on RAG, and the agent was able to understand that, okay, we need to pull the data from here. So as you can see in the video, you have the stock summary, the output, and the expected returns for Palo Alto network is supposed to decrease by this percent and whatnot. So this essentially, so here the agent essentially took a call that, okay, let's go the RAG route and take the data out from there. Now, as you would have seen, this framework actually works pretty well in a sense that it is giving correct, relevant answers. But the proof of the pudding is in the eating, right? If the model is not routing the agent to, the framework is not routing the information to the right agents, then this entire exercise is not going to be worth it, right? So over here, we tested out 3 questions, as we just saw, and all 3 questions have done good on the benchmarks which we have set for the 4 accuracy tools which I had mentioned, accuracy metrics which I had mentioned over there. Now, all the 4 accuracy metrics are meant to talk about whether or not the tool is performing well. Now, the game over here is that, okay, if I have a very high benchmark, then I will have more alerts. But if I have a very low benchmark, I will not have many alerts, but then I'll be very lenient in my governance. And that's something which I don't want to be in. I probably want to be somewhere in the middle. I probably want to understand, hey, okay, if I govern the model in, not very strict, not very lenient benchmark, probably like a 0.6 or a 0.5, that can probably give me an idea whether or not the framework is working, whether or not it is meeting the benchmarks which we have set. So based on the 3 questions which I had asked, as you can see, agent routing accuracy, tool call accuracy, goal completion accuracy, and topic adherence accuracy, all of which talk about whether or not the agent routed well, whether the tool calling was happening properly, whether the goal were completed, and whether the output which we got, whether it is relevant to the topic. All those have, the output which we have got are above the threshold which we had set for them. So in general, this particular framework or this particular window can help the transformation leads, the business folks to understand whether or not whatever framework has been built is correct in in terms of deployment, whether it is sustainable or not. Because building the model is half the battle, because maintaining the model and ensuring that the model is not deteriorating and it is not veering away from the kind of metrics which it is expected to follow, that is the important part of the battle, and that is something which can be achieved via a governance as well. So that said, just to summarize, and because this is the last demo, so just to summarize, for this particular presentation, we went through like an entire journey from the beginning when we spoke about how generative AI spawned into standalone LLM based architectures rather. Then we looked at some kind of agentic frameworks and how agentic AI is transforming industries with some success stories and this demo. So hope this has gotten you guys thinking about how agentic AI can probably change your lives as well in terms of understanding how you can solve pertinent business problems, or you can use agentic AI in that side project of yours, or any kind of entrepreneurial ventures as well. So hope this was good learning for you guys, and we are open to any questions right now. So feel free to ask any questions.
So Sridhar, we have a couple of questions here. Uh, is there a standardized way to conduct task disambiguation before the planner agent step here?
Right. So when you talk about standardized way to conduct task disambiguation before the planner agent, so that is very much dependent on where you want to reach in terms of workflows. Because here, when I spoke about the way that a stock needs to be analyzed, where a report needs to be analyzed, I know the different personas which need to be there. Right. I know like there needs to be 5 personas. One guy is going to be looking at distributing the task. The second guy is going to be analyzing the data and whatnot, right? So the first step is to understand the persona, understand from the business what all things you are trying to create. Because agentic AI is not, it's not a magician's trick, right? It is us creating multiple agents and multiple personas and then tying them all together, right? So just going back, like where just one slide, if you can guys can see this particular part with respect to business understanding and solutioning. This is literally the most important part, in a sense that we need to understand from the business what all personas we are trying to automate, what all decisions we are planning to take, and what all steps we want to create that automation in. So that is one thing which I would want to call out. And just I think there was another question with respect to microservices. The idea over here is that each persona can literally call individual microservices as well. So tool calling is one of the capabilities of agentic AI, right? Now, as you would have noticed in the example which I showcased, where it is calling the Elasticsearch query, it is calling the RAG service. It can be any API endpoint. It can be any framework in general. So that is the beauty of the this entire framework. But the first step is to understand with the business what all personas you would want agentic behavior to be infused into. Hope that answers that
I'd
question.
like to add on a point on this, Sridhar, because
Yeah.
when we speak about the old AI or Microsoft, basically microservices AI, wherein, one thing is that agentic AI is not a step back, but it's a step forward, because here you're not just planning, deciding, acting on its own, but you're achieving a goal also, because so far probably we would have achieved, but as an individual entity. So now you have mass of tools. So whatever the old AI or Microsoft microservices AI, this could be a part of the couple of tools which the agents have. So basically, this could be one of the small tools of all the with the rest. Like as Sridhar rightly mentioned about the tool calling, this could be one of the tools as well. So now coming to the the another question, that is there a guide or recommendation on which sub agents or tools should be configured for a specific domain, and which area should be configured to use RAG? So I'll just start, and probably Sridhar can add to me. So while we started on RAG, the initial process was that before the agents came into picture, we used to basically create the embeddings, store the embeddings in some vector store, and we would query the Milvus for a particular question and get retrieve the chunks and use the LLMs to generate the response on top of it. So why did we use RAG? Because whenever the LLM knowledge would not suffice and we need to give the domain specific knowledge, then we would use RAG on top of it. When we had large document repositories or dynamic knowledge bases, in those cases we had used RAG. Now coming to the agentic based approach, now there's like already RAG has various variants, or there are a couple of variants in RAG itself. So, and again, from use case to use case, the scenario of how we will chunk the data, how we will retrieve the data, because there are various strategy within retrieval as well, and even chunking as well. So it also depends on use case to use case. So when we are saying the sub agents, like in a general scenario, it is like we have a router agent which directs the queries to particular pipeline. Then we have query planner agent, which basically decomposes the complex queries into subqueries for parallel processing, like asynchronously processing. And then we can have a retriever agent, which fetches relevant documents from the vector stores. And then a ranker agent, which basically prioritizes on the documents, basically helps in retrieval. uh, at the end of the day, chunks retrieved will be re-ranked. And then we have a generator agent, and finally validator agent, which verifies the accuracy and completeness with grounding. So this is the minimalistic, yeah, simple sub agent roles in an agentic based RAG. But again, it depends from use case to use case, because we play with the strategies within the RAG as well.
Yeah, I couldn't have put it any better. So, anyways, so I think we'll move on to the next one. Can agentic AI be used as an APM tool? So I'm assuming APM is basically like those application performance measuring tools. So yes, it can, but it bodes well for APM tools to be heavily curated per use case, because when we are doing RCA, when we are doing understanding what was the root cause for any kind of bugs or any kind of outages or any anomalies, so to speak, there are a lot of curated machine learning algorithms which can in theory perform better because they are trained on a lot of data, right? So in theory, you have ML algorithms like clustering, anomaly detection, and a lot of those kind of frameworks which can in theory outplay an agentic framework, because in agentic framework you will probably have to tell the LLM what an anomaly looks like, give it a lot of historic data, and then figure things out. So this is one use case in which probably an APM tool itself might outperform an actual agentic workflow. The next question is, how did you rather help your clients think beyond the AI hype and focus on practical value? So yeah, I'll probably just give my just like a quick 30-second viewpoint on this, and then I'll hand it over to Prajna. But one way which we try and advocate is basically try to understand what exactly is the end goal as far as the client is concerned, because the idea would be to achieve value rather than force fit any kind of frameworks, right? Because we want to ensure that a certain framework is working rather than ensuring that okay, we are adding and subtracting multiple things and then just creating endless complexities. Because in our universe, it's a very well known principle that we operate is that client comes first, in a sense, right? So we try to understand their pain points and then address that, whatever means, and then we take a call on what to do. So if that if that requires to probably veer away from the AI hype, we probably will end up doing that, because at the end of the day we want the client to be satisfied.
Yeah.
Prajna, your thoughts on this?
So what I would say is that, like, just for the matter that AI is very mainstream now, for that matter, we don't encourage the clients to use it. So we understand, we have a briefing sessions. We understand their pain points, understand their daily activities, what do they do, how the process is, and then based on their briefing and our understanding, we propose solutions wherein we find some places where we could have automation, or where we can use AI to bring the benefits. Otherwise, if in a general routine or in their general workflow, if we don't find any place, we don't overfit or use AI for the matter of using AI. We probably sometimes AI may not be needed, because even rule based whitelisting or rule-based approach might solve their problem. So in that case, we will see other areas or other sites where really we can bring value by using Gen AI or traditional ML or any other time series based approach as well. So first of all, in clients interaction, we streamline these tasks apparently that way.
Cool. The next one with respect to security, what are the measures we need to take for agentic AI? Prajna, you want to probably pick this up?
Yes. So basically, with respect to agentic AI, like, see, at the end of the day, like calling the right tool, having that memory, because now the problem of the memory is solved. But especially with a right tool calling and a right tool execution is very important based on the intent of the question as well. So it's very important that, as of now, if like especially with a scenario like leak agent, wherein leak one is be a major leak. So in that cases, we can't restrain the security. We can't put the security at stake, because that will eventually affect the people of that area. So we have to prioritize, based on the current situation, based on the nature of the problem. We streamline or think through that, okay, whether human in loop is to be involved, or human in loop, like for in this case, since league grade 1 is very important, so we would definitely keep the human in loop, at least for now. And but for example, in case of HR assistant, or in case of integrating multiple platforms, here it's okay, like there's nothing at stake, right? As in, we can eventually study the ground truths, study the metrics of this process, and we can correct as well, and we need not take a chance. So in this is how we, as being in leadership position, this is how we envision any pilots. You can add more, Sridhar.
Yeah, I think so. I think that's the the whole point with respect to security as well, because there are some very obvious measures which have to be taken, as Prajna just mentioned. But yeah, it is something of a top priority before we actually get into any kind of these things, because data privacy is the utmost importance when we come to when we deal with client data. The next question is on does watsonx.ai and .gov alone provide agentic AI, or watsonx orchestrate use with AI and .gov make an agentic AI solution? It's actually a bit of both. Sorry to disappoint you with this answer, but it's actually a bit of both, because you can literally do either of them. Orchestrate gives you an additional layer in which the orchestration essentially happens. But the first one is also something which you can use if you want, let's say, a standalone agent which is integrated as an API endpoint to a framework. So, for example, if a client is not requiring that UI layer, rather it requires, let's say, an API endpoint. That's something which we can do in theory, and that's something which is possible only via the very first one, which is the AI and governance layer. So yeah, it can be both of them, and that's a level of customizability which we have reached till now. The next one is with respect to, so is MCP the only advanced protocol for agentic AI? Prajna, you want to talk about it?
Yeah. So while what exactly is MCP? MCP is nothing but basically we want, like for example, earlier we were building normal tools. So there were some built-in tools coming for various frameworks, and sometimes there were no tools. So in that case, we had to build custom tools based on the need of a customer, right? And then came, like for example, especially with the anthropic started this MCP basically. So basically what had happened is that now, okay, I want to take some decision using my agent, but for that I have to build APIs, and I should be able to integrate those systems. For that, my LLM should be understanding that particular systems as well. So MCP is a protocol wherein we have a server, client, and host. So basically, at the end of the day, for each of the applications, say like now Adobe. For Adobe, we have the MCP, or for GitHub, we have MCP. Basically, they are protocols. There's some protocols wherein we can add that as MCP tools in our agentic flow, so that using these tools, our LLM can understand their system and will be able to hit the system. For a simple example, now I want to create some presentation. So, like, how will we use MCP? So using MCP, I will basically clear the slides from the presentation, from my presentation slides. Then I'll go using MCP. I'll do a web-based search. I'll get the details for a particular topic on that subject. After that, I'll paste these results as to this presentation. So all these things can be coupled by using MCP, wherein you have an MCP for various, say from GitHub, I'm getting the code. So there is an MCP server for GitHub from which helps me to connect with the GitHub. There is an MCP server for Adobe, which helps me to connect to the Adobe. And if you have heard about OpenAPI spec, which is basically used for fast API, wherein we have protocols to understand between these systems. MCP is an overhead, or on top of it, it's an extra layer above, which is basically to so that LLM can understand the structure of that particular application, and we can do tool calling, and basically we can use the functions of that particular application and call and do particular action or goal on that particular application. That's the how the overall the MCP is attached to agentic AI.
Cool. We do have one more question here with respect to how various industries implement agentic AI within their cloud FinOps strategies. Now, this is one problem which which, like, there are tools which are actually doing this, but we had taken this up as a hackathon solution as well a couple of months back, and the problem statement was pretty similar in a sense that, let's say if I have a statement saying that I want to build a RAG solution which is catering to 1,500 users, 1,000 queries per day, and what and querying, let's say, a 500-page document, right? Now the idea would be for that statement to be broken down into multiple subparts. The first subpart is going to be looking at the number of users, which basically will tell me about the load balancers and the level of load balancing which I would require in the framework. The second part will be looking at the size of the documents, and then probably talking about the kind of vector databases which will be required, and so on and so forth. Eventually what we tried to come up with was like a matrix of sorts, saying that, okay, if you go with this cloud environment with these configurations, then this would be the cost. If you go with this cloud environment with these configurations, this would be the cost. So agentic behavior can be used to break things down, because at the end of the day, your LLMs are going to have that inherent knowledge of what would be the cost of each each call to a certain LLM and whatnot, based on a certain historic timestamp. So you'll get a generic idea, but you'll not get the exact idea, because LLMs have a training cutoff window, right? So you might probably be cut off because of that. But then again, you can search the web via the agent, saying that, okay, what is probably the cost of each LLM call and whatnot. So based on that, you can come up with the final cost and take a call on what framework to go ahead with. So industries can leverage that, and that's actually a very good use case in order to prove that agentic AI actually brings about, it actually helps in financial planning as well, and collating whatever resources that are required to come up with a logical decision on what to do, what not to do. So yeah, I think we have reached the end of the questions. Hope this was informative, and hope you were able to understand the gamut of whatever we had explained. And yeah, thanks for the organizers for letting us speak. And yeah, I think we are at the top of the hour as well. So thank you so much. Prajna, you have any parting words?
Thank you so much. It was privilege talking to all of you, and I hope the intent was, sharing little bit of knowledge what we know to you, and it could be useful to the developer community. And we are grateful for this opportunity, both of us. And I believe this was valuable for you as well. And thank you so much for this opportunity and for all of you.
Thank you. Bye bye.
Thank you. Bye bye.